Okay. Enthalpy change for a physical transformation. The intermolecular forces of attraction between atoms, ions, or molecules are strong and solid. So, energy is to be supplied to solid into liquid state. Similarly, liquid is changed into gaseous state by the application of heat. Hence, physical change of chemical substance are accompanied by change in enthalpy. Physical change of chemical substance are accompanied by change in enthalpy. The enthalpy of physical change can be expressed as flows. Enthalpy of fusion, heat of fusion, the quantity of heat change involved when 1 mole of the solid substance is converted into liquid state. At its melting point is called enthalpy of fusion. 1 mole of ice melts to form water by absorption of 1.43 kilocalorie energy at 1 atm pressure and 0 degrees Celsius. Hence, heat of fusion of ice is 1.43 kilocalories per mole. Ice converted into water. 1 mole of ice converted to 1 mole of water. That is the heat of enthalpy of fusion or heat of fusion of water. Enthalpy of fusion is also called latent heat of fusion. Greater the intermolecular forces of attraction in the solid, greater will be the quantity of heat required to break the bond, and hence greater will be the value of enthalpy of fusion. Hence, enthalpy of fusion is the measure of strength of intermolecular forces of attraction. Low values of enthalpy of fusion indicate the weak molecular interaction in the solid. Ionic compounds have strong intermolecular forces of attraction due to strong ionic bond. Hence, ionic compounds such as sodium chloride, potassium chloride, barium chloride have the high value of enthalpy of fusion. Molecular solids such as helium, argon, methane, have weak intermolecular forces of attraction due to weak type of van der Waals forces, and such type of compounds have low value of enthalpy of fusion. Conversion of solid into liquid is accompanied by the absorption of heat, so delta SF has positive value. Conversion of liquid into solid is the reverse process of fusion, so the freezing process is accompanied by release of energy. Hence, enthalpy of freezing has negative value of delta S. Liquid water converted into solid, delta S minus 1.43. Enthalpy of vaporization, heat of vaporization, the quantity of heat change involved when 1 mole of liquid is converted into vapor at its boiling point is called enthalpy of vaporization or heat of vaporization. Boiling of liquid is endothermic process. 1 mole of pure water is converted into water vapor at 100 degrees Celsius and 1 atmospheric pressure by the absorption of 10.52 kilocalories heat energy, and enthalpy of vaporization of water is 10.53 kilocalories per mole. Water, liquid water converted into vapor water, enthalpy change to minus 10.53 kilocalorie. Enthalpy of vaporization is also called latent heat of vaporization. Greater the intermolecular forces of attraction between the liquid molecules, and greater will be the quantity of heat required to break the intermolecular bond, and hence greater will be the value of enthalpy of vaporization. The intermolecular hydrogen bond is stronger in water than that in the ethyl alcohol. This necessitates high energy to break the intermolecular forces in water, and enthalpy of vaporization of water is expected to be greater than that of the ethyl alcohol. This fact is justified by the value of enthalpy of vaporization. Enthalpy of vaporization of water is 10.53 kilocalories per mole, while that of ethyl alcohol is 7.29 kilocalories per mole. 1 mole of ethanol liquid converted into ethanol gas, heat of vaporization equal to 7.29 kilocalorie per mole. Okay, it's the okay, sorry. 1 mole of ethanol liquid converted into 1 mole of vapor ethanol. Volatile substances have relatively low heat of vaporization. Enthalpy of vaporization may be regarded as the measure of intermolecular forces of attraction in liquid molecules. Enthalpy of vaporization is endothermic process, so delta SB has positive value. Condensation is the reverse process of vaporization, so condensation is accompanied by release of heat energy, and it is exothermic process. For example, conversion of 1 mole of water vapor into liquid water at 100 degrees Celsius and 1 atm pressure releases 10.53 kilocalorie heat energy. Vapor water changes into liquid water. Enthalpy of sublimation, heat of sublimation, the quantity of heat change involved when 1 mole of solid substance directly converted into vapor state without being the liquid is called enthalpy of sublimation, or converted into vapor state without being the liquid is called enthalpy of sublimation or heat of sublimation. In fact, sublimation of a solid takes place below its melting point. Sublimation of solid into vapor phase is endothermic process. 1 mole of pure iodine changes into its vapor phase by the absorption of 14.92 kilocalorie energy. Hence, heat of sublimation of iodine is 14.92 kilocalorie. Solid iodine changes into gaseous iodine. Uh, Greater the intermolecular forces of attraction in the solid phase, greater will be the enthalpy of sublimation. Enthalpy of sublimation is the measure of the intermolecular forces of attraction between the molecules. Sublimation is accompanied by absorption of heat. Hence, delta Has has positive value. Heat of sublimation is taken as the sum of the fusion and heat of the vaporization. Enthalpy of transition, heat of transition, the quantity of heat change involved when 1 mole of substance it changes from its one allotropic form into another allotropic form at its transition temperature is called enthalpy of transition or heat of transition. 1 mole diamond is converted into graphite at 25 degrees Celsius temperature. 0.45 kilocalorie heat is released. Diamond change into graphite. One phase to the another phase, that is the exchange, minus 0.45 kilocalories. The reaction shows that the graphite is thermodynamically more stable than diamond. But conversion of diamond into graphite requires high activation energy. Hence, diamond is thermodynamically less stable while kinetically more stable. Enthalpy of atomization, heat of atomization, the quantity of heat required to produce 1 mole of gaseous atoms from the stable element is called enthalpy of atomization or heat of atomization. In case of solid substance, heat of atomization is equal to heat of sublimation. Carbon graphite crystal converted into carbon gaseous state, gaseous atom. So delta is equal to plus 171.45 kilocalorie at 25 degrees Celsius. It is to be noted that graphite is more stable from a stable form of carbon than diamond. So heat of atomization is measured with respect to graphite. In case of homonuclear diatomic gases, the heat of atomization is equal to half of heat of dissociation value. Hydrogen converted into atomic hydrogen, 104.3 kilocalorie, and hydrogen atom of 52.15 kilocalorie. Dissociation of 1 mole of hydrogen gas produces 2 moles of hydrogen atoms. So dissociation of half mole of the hydrogen produces 1 mole of hydrogen atoms. Hence, heat of atomization of 1 mole of hydrogen is half heat of dissociation of 1 mole of hydrogen molecule.